Hey, Allie. We are on the middle of the first page of 2.5, and we are going into like the bottom examples, the bottom three examples. So here we go. This thing is called the rational zero test. And before we talk about that, let's look at these three examples that we did before when we're trying to find the zeros. Okay, so trying to find the zeros, we can factor them down. We can try to pull stuff out like the greatest common factor method. We could try to do the difference of squares, factor by grouping, those type of things. Okay, the rational zero test is stuff that like is so big. Like here is x to the fourth. We have 5 pieces here. There's no way I can factor stuff down when he's 5 pieces long. Okay, and so like when everything else fails, like there's no way of me factoring that down because he's a cubic function, right? Like when he's so big and when everything else fails, we do the rational zero test, which I call the P over Q method. Okay, P over Q method. It's kind of unpleasant. It really actually is. The P over Q method. It's not too bad, but it's just cumbersome. It's very cumbersome. Okay. So the P over Q method. All right. P is the last number. Okay. Factors of the constant term. The last term over the leading coefficient. Okay. The last term, the leading coefficient. So if we just look at, what are you talking about? Like for this one, number 1, the P is the last term, the Q is the like first piece, right? If they're in order, right? They have to be in order first. Whoa. Do you guys hear ringing? No, yeah, my ear just went out. Do you hear it? What is that?
Yeah.
You hear it ringing?
Is it the light?
I don't know. I don't know if my ear just went out
or
what.
It the thing outside again?
I don't know. It sounds like when somebody like on their phone, like only 25-year-olds and below can hear this, and it's like one of them things. I don't know. I can't hear it now. I don't know. Anyway, all right, whatever.
Oh, but this feels nice.
So P is this guy, Q is this guy. So P is 1 and Q is 1. Well, what about that? That's exciting. P is 1, Q is 1. So we list not just those numbers, but we list the factors of those numbers. So like the number 1 goes into 1, but also -1 goes into 1, right? Okay. So plus and minus 1 factors of 1 are also plus and minus 1. So when I reduce that, plus minus 1 over plus minus 1 just gives you plus minus 1. So what this means is that
that equals 0 is yes.
This is the list of possible zeros. Okay, meaning if it is not in this list, it is not a zero of this function. Like the number 5 is not in this list. So it is not, there's no way 5 could be a place where he crosses. There's no way that 5 could be a zero of this function. There's no way that 7 could be a zero of this function because it's not in this list. Now, it could be a decimal, which is an irrational, or it could also be imaginary. So if it's not in this list, if not in list, it could be a decimal or imaginary, okay? But if it's a whole number and it's not in that list, there's no way it could be a zero, right? Okay? So what we're going to do is we're going to find the rational zeros by, we listed the possible ones. Now how do we see which ones actually work? You plug them in. So we're going to plug 1 in, and then we're going to plug -1 in. 1 cubed plus 1 plus 1. That turns out to be 3. So +1 is not true because we're looking for it to be 0, right? Okay, then we do -1.
-1 plus -1 plus 1.
-1 plus -1 plus 1 is -1. So -1 doesn't work either.
Then they're imaginary, or they're above the axis. What are we looking for?
We're looking for the nice places where he crosses. We're looking for the actual zeros of the function. We said that +1, -1 are the possible ones, but we want it to be 0, right? If you plug him in, right? Like if we plug him in, then that means that he has 0 remainder, right? Okay. Because we're looking at factors. So P is 1 and Q is 1. So we're looking at factors of 1. Our positive -1, positive -1. We have to do plus and minus for each one. So what the heck? We don't have 1 or -1, right? They could be imaginary, right?
So it's not plus and minus because when you plug
Because when we plugged them in, they didn't come out to be zeros, right? Right. So we don't have any rational zeros. So there's no rational zeros. Does that mean he doesn't have any zeros at all?
No.
Okay. What's the minimum number of zeros that this function can have?
1.
He has to have 1, right? Right? Do you know why he has to have 1? He's an x to the third power function, so he's got to go up and down forever, right? But so he has 1 at least, right? But what is that 1 that he has?
Imaginary.
It's going to be a really ugly decimal, right? Okay, it's not imaginary because he does have 1, right? But the other 2 might be imaginary, right? He has 3 total. So I'm guessing, here's my guess. I would guess 2 zeros are imaginary, and I would guess that 1 0 is irrational. Okay, irrational meaning like the square root of 3 or something like that, right? Okay, so he's a decimal and he's irrational. He's just really ugly, right? Okay, he's not a whole number. Okay, because we're only finding the rational ones. And he has no rational places. He has no places he crosses nicely. I'm going to show this.
Hey, why?
I'm freezing.
I stopped that.
Okay, number 2. Let's do this one. Here we go. What's P?
6. -6.
-6. Well, yeah. Okay, and then no matter what, you're going to end up listing the pluses and minuses. So -6, +1, those are my P's and Q's. So -6, +1. If I list out factors, what are factors of 6?
1, 2, 3, and 6.
±1, ±2, +3, +6. Okay, and factors of 1
+-1.
are +-1, and that's it, right? So I do 1/1, 2/1, 3/1, 6/1, which is just really +-1, +-2, +-3, +-6. Okay, we're talking about factors or numbers that go into 6. So 1 goes into 6, but also -1 goes into 6. 2 goes into 6, but -2 goes into 6. 3 goes into 6, -3 goes into 6. 6 goes into 6, -3 goes into 6. Or -6 goes into 6. So those are the only possible rational ones. They're either decimals or imaginary if it's not one of those. How many possible rational ones do we have?
Possible?
8. We have possible 8, right? 8 possible. So let's check to see which ones come out nicely. Would you like to divide and conquer?
I guess.
Everybody takes nice ones. All right, Mallory's got 1. So she's plugging 1 and -1 in. You got the 1s, right? You got 2s and -2s. Maddie? Ellie? You don't care? Maddie's got the 6s. Ellie, you got the 3s. Okay? So do the positive and negative of those guys. So plug them in, see what you get.
-1 works.
-1 works? Does +1?
No.
No. So -1's on the list. Okay, anybody else tell me?
-3 does not.
-3 does not?
The -6.
+2 does? Okay, what'd you say, Maddie?
-6 doesn't work.
Does not work? Okay, -6 does not work? Did you do +6 yet?
No.
Okay, you're doing the -1 first. Then you can just delete out the negatives, right?
3 also does not work.
3 does not work, okay. Can you what? Retake your test? Sure. You know when? This period? Tomorrow, 8th period? Okay.
+6 also does work.
-6? Okay, so none of those work. So the only rational ones are -1 and 2, right? Okay, how many should this guy have total?
4.
He should have 4, okay, but we only got 2 rational ones. So the other 2 are either,
Or icky.
imaginary or icky, like you said. Decimals, which are like irrational, which are like square roots of things, right? Okay, makes sense? Well, we have 2 nice places that he crosses, -1 and 2. There he is. Okay? All right, let's go to the next one. Oh, these are ugly.
3.
3. Okay, so P is
3.
3 and Q is
2.
2. So we've got 3 over 2. Factors of 3.
Plus minus 1, plus minus 3.
Plus minus 1, plus minus
1,
3.
Plus
Plus
2,
minus 1, plus minus 2.
1, plus minus 1, plus minus
Okay,
half,
so 1 over 1, 3 over 1, 1 over
plus
2, 3
minus
over 2. That's disgusting.
plus minus.
1 over 1 is plus minus 1. 3 over 1 is plus minus 3. 1 over 2 is plus minus, I'm going to say 0.5, so he's nice to plug in. Plus minus, the last one is plus minus 3 over 2, or I just lost my marker. Plus minus 1.5.
Oh, 1.5.
Right. There's those 5.
I'll take 0.5.
Okay. Mallory's got 0.5.
I got
1.
Oh, 3.
Ellie, Maddie?
What's the other one?
3 and 1.5.
I'll take 3.
You'll take 3? Ellie got 1.5. The positive negatives. Those guys. This one's a little bit shorter to plug into. It's only got 4 terms. Which one of those works and which one doesn't work? We should have 3 total. We should have 3 total, but that doesn't necessarily mean we're going to have 3.
Positive 0.5 works.
Positive 0.5 works.
Negative 3 works.
Negative 1 doesn't work.
Negative 3 works. Which one did you say doesn't work?
Negative 1.
Negative 1.
Negative 0.5 does not work.
Negative 0.5 doesn't work. Okay. We got 2 of them. We got negative 3 and we've got positive
1 works.
0.5. 1 works? Okay, then we're done. Stop. Well, stop where you are.
Oh.
Because we have all 3 of them, right? None of yours are going to work. All right, so we found all 3 of them. All 3 of them are rational. All 3 of them are semi-nice, right? Even though it's 1/2, it's semi-nice of a number, right? No imaginary zeros, no irrational zeros, like square roots of stuff, right? They come out really nice. Those 3. And then we're done. We got those guys. Okay? Let's go to the back side. Let's see what all we have here. Good? I'm going to move on. Complex zeros occurring in conjugate pairs. Okay. Example. Find a 4th degree polynomial function with real coefficients that are -1. Oh, with real coefficients that have -1, -1, and 3i as zeros. Okay, here's the deal. When it says that those are zeros, that means that x equals those, right? So x equals -1, x equals -1, and x equals 3i, right? Why did they put -1 like double down there?
Multiplicity of 2.
It has multiplicity of 2. What happens when it has multiplicity of 2?
It touches.
It touches, but it doesn't cross, right? Okay, now here's the deal. Whenever you have an imaginary number, they always occur, or a square root number as a 0, they always occur in conjugate pairs. You cannot have one without its conjugate, okay? What's the conjugate of 3i? Negative 3i. So even though they did not tell me that -3i is a 0, I have to assume that it is, because the only way of getting 3i is from the quadratic formula, and the quadratic formula never exists without conjugates, right? Plus minus, okay? So we have all 4 of them. That's my 4th degree polynomial, and then we just have to multiply stuff together. This is kind of a little bit ugly-ish, okay? So if I write out this guy as a factor,
Plus 1, x plus
that'll be
1,
x plus 1,
x minus 3i,
x plus 1,
x plus 3i,
x minus 3i if I move him over, and x plus 3i.
x squared plus 2x plus 1,
She's just on a roll here. Heavens to Betsy.
x squared plus
All right, so she just multiply those 2 together, right?
squared,
Mallory's just going. She's
x
just got it.
minus 3
X squared plus 2x plus 1, right? If I multiply those together and combine the middle 2 pieces, can I do that?
x squared
Yeah? That's those 2 multiplied together. Then let's multiply these 2 together.
plus 3
Okay. X times x is x squared. Then we've got, oh heavens, this is plus 3xi. But then we've got minus 3xi, or ix, or however you want to write it. And then what's -3i times positive 3i?
Oh, it's a -3.
Negative 9i squared.
Which makes it positive.
Which is going to
9.
turn this to be a plus 9. Okay, so I've got this guy, and then I've got these 2 cancel out, so the other piece is x squared plus 9. It's like the sum of two squares, x squared plus 9.
I
Okay.
got it.
Then I have to multiply that together and combine like terms, then I'm done. Okay. All right, are we going too fast?
No, you're fine.
Okay. All right, so x to the fourth plus 9x squared plus 2x cubed plus 18x plus x squared plus 9. Did I do all that right? Something like that? Let me just combine stuff. X to the fourth is gone. Plus 2x to the third is gone. Plus 10x squared.
I don't know what happened.
Plus 18x plus 9. I'll zoom out. There is my quartic function. There he is. Quartic function. He is icky, yucky, yucky, yucky.
Is this on our homework? Probably, sadly.
I think, yeah, they think there's one like that. Do you want me to zoom in somewhere, Maddie? This is probably one of the longer lessons that we've had in this chapter. What?
Are we doing review next week?
Probably. No, we only have Monday, Tuesday. Monday you guys are gone. Tuesday's turkey trivia, so no, it'll be the following week.
What about Thanksgiving?
What? Turkey
I gotta
trivia?
figure out what turkey trivia to give you because you guys have all had it before, so I'll have to do a
You
second
think
set.
we remember that?
Yeah, you'll remember. You'll remember.
Wait,
Yeah.
so what? Can you repeat our next schedule?
So tomorrow we'll do the last section, which
No.
is 2, 6.
Is it short or long?
It's short.
Okay.
I think.
Friday,
And
we'll
then-
review.
Friday. Oh yeah, tomorrow's Thursday. Friday I'll give you the review, but then we won't do anything with it until the following
So
week.
the month that next, we're gonna be gone that next Monday too.
For what?
One act.
Oh, one
Then
act.
we're done.
Good
Unless
heavens.
we make it stay.
Jeez, that's right in a row. They make you boom, boom, boom. Okay. All right, are we ready to go to the next one?
How'd you guys do without Ashley?
Find all the zeros. Find all the zeros. Here we go. Find all the zeros. Here is my function, and I know that
60
1,
over
this
1.
is disgusting. I know that 1 plus 3i is a 0 of the function. That means x equals 1 plus 3i, okay? But also, if that's a 0, I also know that x equals 1 minus 3i, okay? Now, this is really disgusting. This is really disgusting, okay? What does this thing look like as a factor? Ew. What's he look like as a factor? If I move these guys over,
X
x
plus 3i.
minus 1 minus 3i.
Okay, whatever.
Disgusting.
Wait, what?
Okay? If I move the 1, we know that x equals 1 plus 3i if that is a 0, right? And then if we move him over, we move both of those pieces over to get the part that's in the parentheses. And that's what he looks like as a factor, right? Okay, what's the other one look like as a factor?
X minus 1 plus.
I'm going to write them next together. I'm going to write x minus 1 plus 3i. Okay, and now we're going to FOIL that out, which isn't a FOIL. It's like 6 pieces. Actually, 9 pieces. Heavens. But there's going to be things that are going to cancel, so it's going to be okay. All the i's should go away eventually. Okay,
Wait, so what are we doing with that?
we're going to multiply those together. You'll see here in a second. X squared
2x.
minus x plus 3xi. That's this, right?
Oh, I'm skipping.
Okay. Minus x plus 1 minus 3i.
Well, the pluses and minus get away, so it's x squared minus 2x plus
Okay.
1.
Minus 3xi plus 3i minus 9i squared.
Ooh.
Blah, blah.
I squared is -1.
Yes, so this guy can switch. He can become plus 9. Right?
So it's
Okay, and then let's cancel some stuff. So 3xi minus 3xi, 3i and 3i, those cancel.
So it's x squared minus 2x plus 10.
X squared minus 2x plus 10. Okay? So, I know that this is one of the factors that goes into this guy.
break her down into 2.
Well, I don't want to break her down into 2 because I know what the 2 are. It's these 2, right? I don't want to go backwards.
Oh.
So we're going to do some division to
What?
get what's left over after I divide this guy by this guy.
Oh, no.
Oh, man, because we've got to find all of them, right? It says find all the zeros. So we know 2 of the zeros.
1, -3, 6, 2, -60.
Nope, you can't do that.
Oh,
That's
we have
synthetic.
a
We have to do
divide.
long.
I hate it.
We
here.
have. You hate. What did you just say?
I said I hate it here.
I hate it here. Oh, boy. Okay. So here we go. I'm going to just write it next to it. X to the 4th minus 3x cubed plus 6x. Now we know that it should go in there nicely with no remainder, right? Because these are zeros. They already told us that. Okay. So he should have no remainder at the end. Okay. Are we ready for some long division? Multiply is x squared.
X to the 4th minus
Multiply back through.
2.
No, wait. Okay, I'm waiting.
Down.
I'm waiting.
Thank you.
Yep, you're welcome. You just tell me.
Okay, wait. So why are we dividing it again?
So it says it wants us to find all of the zeros.
Okay,
So we know 2 of the zeros because we know they gave us 1 and then we know his conjugate also. So we multiplied them together to figure out what that is as a factor, like together, and then we're going to long divide and then see what's left over, right?
I lost those algebra-y stuff.
There's a lot of algebra-y stuff here.
Oh,
This
no,
is
Allie's probably cheering right now on the other side of the camera.
why?
Because she loves algebra stuff.
Yay! Allie!
Allie, I
Go,
hate
Allie,
algebra.
go. Go, Allie, go. She likes algebra. Yeah. My Algebra 2 kids are learning synthetic division today. We
Yeah.
learned long division yesterday.
Yeah, I saw that.
So, anyway. All right. So, okay, we ready to go? X squared, multiply the x squared back through. We have for x to the 4th minus 2x squared and then plus 10x. No, 2x cubed. There we go. Plus 10x squared. There we go. And then we have to flip the signs. So minus, this guy becomes a plus, this big guy becomes a minus.
I got confused.
You think you got confused? Okay, see, just follow along and see where we go.
I wasn't following.
And then the extra fourth
Okay,
is
so
equal.
minus x to the 3rd, because we have minus 1x to the 3rd, minus 4x squared, and then I'm going to drop the 2x down, so plus 2x. Did you get stuck there? Okay.
I forgot to switch my type to negative.
Ah. Yes.
No, wait. Then you'll see what goes in.
Okay, so now we start again. X squared, what do we take times it to get negative x cubed? Is negative x, right? And that becomes negative x cubed plus 2x squared. No, it doesn't look like a plus. There we go. Plus 2x squared. No, yes, plus 2x squared minus 10x, and then we flip signs again. So plus, minus, plus. I like doing this with 2 different colors.
Something on. What did I do?
I'm gonna run out of room.
I know, I am too. Kinda. Maybe.
It does not.
There's only one left though. We have negative 2x squared plus 12x minus 60. Did we do something wrong? Oh, no. This is negative 6 because that's a minus 2. So this is negative 6. There you go. There we go. We are going to cancel. Negative 6x squared
Oh, that's
Plus
It's a
10x.
positive.
minus 60.
It's positive 2.
Plus 12.
Because it's negative x and negative 2, so it's plus.
No. Yeah, it's plus, but then you have to switch the sign, so it's minus.
Plus
Right.
12x,
We didn't
though,
switch
not
the
plus
signs
3.
because it was negative in the first place.
Oh, plus 12. Yeah. Yes, correct. Plus 12. There you go. Thank you. Just keep yelling at me until I listen. Okay? Did we get it solved, Mallory? We got it figured out? Okay. All right, then what do you take times x squared to get negative 6x squared? Minus 6. So multiplying back, negative 6x squared plus 12x minus 60. Flip the signs. I'm going to flip the signs a different color. Plus, minus, plus, and he comes out to be 0 as a remainder. Yay! Okay, so after I divide that off, what I have left over is x squared minus 2x. No.
Minus x.
Blah, blah, blah. Minus x minus 6. I was ready to write the other thing again. Minus 6. And then he is nice, though. He is a
2 and
quadratic.
3.
2 and 3. You're right, 2 and 3. X minus 3x plus 2. So what are my zeros?
X equals 3, x equals negative 2.
X equals 3, x equals negative 2. So it says find all of the zeros. Okay, I have my list off to the side over here to see my list over here. So let's just add them to that list. So we know that x equals 1 plus 3i and 1 minus 3i. And to that list I can add x equals 3 and x equals negative 2. And that is all 4 of my zeros that I should have, including the imaginary ones.
What about, why did you have negative 3i?
Because they always go in conjugate pairs. Every time you see an imaginary number or a square root, they will only ever go in conjugate pairs. So you have to include the other one as well. Because the only time you ever get a square root or imaginary as a 0 is when you're using the quadratic formula. And it never has one without the other. It's always plus and minus.
Okay.
Yes. Okay, good. All right, last example, start to finish. We got lots of room here, so that's exciting. Okay, we are going to have 5 factors as a product of linear factors and list all of its zeros. Okay, we have 5 answers, all right? We just pray that all of them are rational, right? And then we're done. Okay, so let's start with the P over Q method to see where we get. Okay, P over Q, here we go. 8 over 1, which is nice. That's kind of nice, right? Plus minus 1, plus minus 2, plus minus 4, plus minus 8, all over plus minus 1. So it's 1 over 1, 2 over 1, 4 over 1, 8 over 1, which is just the same as the top one. So we have 8 possible ones. Please give us at least like 3 that are nice. That would be awesome. That would be 3. Okay, you want the 2s? Allie's got the ones. Ellie's got the ones. Because you've had some doozies. You've had the doozies. You had like 6 and. Okay. All right. That means Maddie, you got the 4s.
Hey, do we have to put 0? Or it's not gonna matter.
What? No, you don't have to put zeros in for this. No. I see what you're saying. No, you don't have to. Okay. Tell me what you get. If you get one that comes out nice. Okay. Again, they're trying to come out to be zeros, right? When you plug them in.
No.
Oh, my negative 2 works.
Negative 2 works. Yay.
It does not work.
8? Positive 8?
Yeah.
No. Okay.
Negative 4 is no.
Negative 4 is a no. Okay.
Negative 1 is no.
Negative 1's a no. Oh, come on, guys. Help me out here.
Positive 2 does not work.
No!
Told you.
3 left. Come on. Come
No.
on. No! Maddie, you had 4?
Yeah.
No.
Oh, 1 works.
Ah! Yay. You can stay. Everyone else, you get kicked out.
Well,
Hold on.
Negative 8? Michelle?
No.
Come on. No! We have 2 of them. Dang it. How are we going to do that? 2 is all? Okay, we have negative 2 and positive 1.
Yeah.
Those are the only ones that we have. Okay, so we got to reduce him down. He's x to the 5th power. So now we have to find 3 more, right? Okay, so now what?
we don't. I think we're fine.
You think so?
I think 2 is good enough.
I think we're good.
You think we're good? Okay.
Yeah.
Now what?
No.
Let's do some synthetic. We can at least do synthetic on this. Okay, we need to put a 0 in for the x to the 4th, though. So we have 1, 0, 1, 2, negative 12, 8. Allie! Allie, you just showed up on the in class. Allie. Okay.
We have a video of you.
Are we
For you.
doing?
We have a video for you.
Negative
You're on
2.
video.
You're on your own video. There you go. Okay. This is negative 2, right? Okay. So I'm going to go fast. Can I go fast? 1, negative 2, negative 2, 4, 5, negative 10,
No.
negative 8,
Oh, that's a 1? I put it.
positive 16, positive 4, negative 8, and 0.
Like
There's my
80% of
remainder.
time on synthetic division in this class, I'm like just trying to keep up with numbers.
You know what? I'm done.
You're done.
Yeah.
You're done. Oh,
Weird.
I know. There's something else that we can do, folks. I know what to do. I know what's going to happen. Okay, let's do synthetic division again. So off of this thing, we have 1 here, right? Okay, and we do it again. So drop the 1, and that is 1, and that is negative 1, and negative 1, and 4, and 4, and negative 4, and negative 4, and 0. There's my second synthetic division.
Yay, there's a 0.
Okay. All right. Now, one thing that could happen is that negative 2 could occur twice or 1 could occur twice, right? Because we have 3 more left to find, but we could have negative 2 and 1 occurring more than once, right? Okay, so you just watch, because I can erase if it doesn't come out nicely, right? So you just watch and we'll see if he comes out nicely. So do you want to try -2 again, or do you want to try 1 again? -2,
One.
let's do it. Let's do it. Okay, don't write this down. I'm going to write it down, and then I will erase if it doesn't come out nicely. So 1, -2, -3, 6, 10. Not going to work. Not going to work. Not going to work. Okay, so let's go back to 1 again. I know. Please, 1, work. 1, 1, 0, 1. No. 5, 5. Did I do that right?
Yeah.
No, 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 no. I screwed up. I screwed up. I screwed up.
0.
This should be 0 again.
I've never heard the excitement that much.
It's gonna work!
1 shows up twice.
Wow.
So then, do you know what the power of this guy is?
Multiplicity of 2.
He has, what's his power? Is that 1x to what power? He was 5 to start with. We
second
found 3. So this is x squared. So this is just x squared plus 4, right? 1x squared plus 4. Yay! So then if I set AB equal to 0, what are the zeros then?
X equals plus
X
minus
squared
2.
equals -4.
Or 2i
right?
plus minus
X
2i.
equals plus minus 2i. Those are my zeros, okay? So let's list them out. We have product of linear factors. Okay,
X
so
equals -2.
we have -2,
1.
1, 2i, and -2i. Those are my 5 guys there, okay? And then they want to, as a product of linear factors, so that would be
So-
like x plus 2, x minus 1, x minus 1, x minus 2i, and x plus 2i. Those are my linear factors. It wants both of them listed out like that. Yay! So that's a thing. They could occur more than once. Haha! I'm so glad we located that. That's very exciting. Good, good. Okay? All right, I'm going to stop the video. Bye, Allie, even though you're here.